get you 1. All right, Ex3H quadratic formula. Today's part should be the easiest part because it's just one formula you need to memorize, which I already typed it up for you. This is usually in your test, so you don't technically have to memorize it. It's good to memorize it though. It's like your times tables. At some point, you can always refer to the times tables chart, but it's nice that you learn it, right? Because as you learn it, it helps you to move forward much quicker and easier. Same thing with the quadratic formula. When you're stuck, you can't do completing the square, or you can't do cross method, or you can't do dots. Technically, completing the square, you can always do it, except when it's, actually you can always do it. It's just that when the numbers are really large, that's when you know to use quadratic formula because you can't be bothered going through all the factors, and this will definitely give you the x-intercepts. Okay, so as a summary, the general quadratic equation is this one. So we know all quadratic equations will be y equals ax squared plus bx plus c. And then you can find the x-intercepts by using, and this is called your quadratic formula. And don't confuse this formula with this one, because they're both equal to x, but they're not the same x's. What's the difference between the two? Hands up. Anthony. Very good. This one is your x, and if it helps you, just put a note here. That's your x-intercepts. This formula literally comes from letting y equal to 0 right now, and they actually did complete the square of this with a, b's, and c's, and then they did difference of perfect squares with these a, b's, and c's, and they rearranged everything to get that. That's essentially what they did. Okay, so you can look at the proof. It's in your textbook. It's a whole bunch of algebra, but all they did was to find x-intercept, let y equal to 0, so you're trying to solve for ax squared plus bx plus c, and I've taught you how to complete the square, but remember the number in front of x squared has to be 1, so they had to factorize a, take out a out. That's why you get, I'll just show you the next step. I'm not going to show you the entire thing, okay? So I'm taking out a. If you take out a, you get x squared plus b over ax plus c over a. You see what I'm doing? Because a times x squared is ax squared. A times b over a, the a's cancel out, so you get bx. And then a times c over a, so a cancels out again, that's how you get c. That's where your b on a is starting to come out about, right? So from here, complete the square the way I've taught you. Half the b term, add on the squares, and subtract the squares. And then you do difference of perfect squares. That's how they get this, okay? So that is your x-intercept. This, I can't show you the proof until the end of the year. When you learn calculus, this is your axis of symmetry formula, which for a lot of students who don't understand the terminology, I just tell them it's your x-coordinate of the turning point, which is not true. Okay, it's not true, because when you write x equals to a number, see if I actually type it on Desmos, see if I actually go back to Desmos and I type in x equals 3, x equals 3, I don't get a dot. It's not the x coordinate of a turning point. It's an actual vertical line. This is your axis of symmetry. That's where it's going to be symmetrical, but it helps you understand that wherever the quadratic is, that's also where the x coordinate of the turning point is. So it helps you remember easier because this makes more sense to you. This language, not a lot of students understand, but really that's a vertical line. That's the vertical line that cuts the parabola in half. That's why we call it axis of symmetry. Okay? So 2 different formulas. How do you use it? Same thing. You need the general equation, a, b's, and c's. If you got them, plug it into the formula, and you get your answers. But just knowing the difference, when do you use either one? That's the only thing you need to understand. Okay? So today's lesson, let's fill out some things that you would have learnt last year. Last year, inside the square root, there's this b squared minus 4ac, which is powerful. So next week, that's what we're going to be focusing on. There's a name for it. Anyone know? Starts with D. Anthony again. Discriminant. For now, you're going to memorize this. Next week, I'll explain why these 3 conditions you have to remember. But if you understand it, you don't have to memorize it. It just makes sense. Okay? So here, discriminant. Last year, they said if the discriminant, so if whatever this number is, b squared minus 4ac, if that ends up being less than 0, which means it's negative, what do we know again? What do they say? Hands up. If discriminant, oh, by the way, the symbol for it is this triangle. So you can say if discriminant is less than 0, then no solution. So write that in if you didn't know. So you're going to memorize these facts. The other one is if discriminant is equivalent to 0, then you have, hands up. That's it. One solution. They call it unique solution or one solution. And then when you have b squared minus 4ac, which is discriminant greater than 0, meaning it's positive, then how many solutions do we have? Hands up. See ya? Two. For now, that's all you're going to remember. Now, when we say solutions, for those who don't understand what solutions mean, it's just what makes the equation true. In our case, this is related to the x-intercept, so it literally means no x-intercept, one x-intercept, two x-intercept. Later on, because you might be working with other functions, it may not be relating to the x-intercept. That's why we call it discriminants and solutions. All right? But for this context, it will refer to the number of x-intercepts. So here you'll have 0 x-intercepts. Here you will have 1 x-intercept. And here you'll have 2 x-intercept, which makes sense for a quadratic graph. You can either get no x-intercept, exactly 1 intercept, so it might sit exactly right on the axes, or you could have 2 intercepts. Okay, those are the only 3 scenarios you can get. You can quickly determine how many x-intercepts you have just by looking at b squared minus 4ac. Next week, we'll talk more about that. Okay? All right. Oh, I could have just drawn it here. No solutions. Unique solution. Sits on the axis and then crosses through 2 x-intercepts. All right, there we go. Let's do some examples. That's pretty much 3H. If you needed to understand what you needed to know, this is, to me, the easiest exercise because you just need to memorize the rule and then just apply. So let's have a look at the example that you might have down here. It says, determine how many x-intercepts there'll be for the following shown below. So you've got x squared plus 7x minus 1. Notice it's equal to 0. It's because I let y equal to 0 and I'm trying to solve for x-intercept. Same thing with this one. I've got x squared plus 4x is equal to 0. I'm trying to solve for the x-intercept. Again, you can factorize it and then solve it. You can tell how many solutions, or you can use what we just learned. So let's practice what we just learnt. What is my A, B, and C, Lucky? A is 1 because there's a number in front of x squared. Yes, that's 1. B is 7 because it's a number in front of x. And C is definitely -1. So be careful with the sign. So yes, that is correct. It's -1. So putting it together, how many solutions? Well, we know that the discriminant, which is b squared minus 4ac. Let's solve for that. B squared, so that's 7 squared minus 4 times a, which is 1 times c, which is -1. Notice my layout. I'm using the brackets to separate, especially when you start doing indices and all that. So you got 7 squared, which now we know is 49, plus 4, because doubled negatives become positive. -4 times 1 times -1. And that gives me 53. Pretty much, you don't really need the actual number because the question didn't ask what the discriminant was. The question asked how many solutions can you expect. By this point, we should already know how many solutions do we have. 2, because the number is greater than 0. So if it's positive, you got 2. So sometimes I even get to this point, I don't even bother working out what the value is. I'm just like, all right, 2 solutions. Okay, so from here, we know that the theory is the discriminant is clearly going to be greater than 0. So therefore, 2 solutions. So for the second one, I can quickly look at it and already know as well because I can factorize that and can see how many x-intercepts you'll get. But let's say you didn't know. Let's do it again. A is equal to, B is equal to, and C equals 2. Namafi? What's my A, B, and C?
A is 1, B is 4.
Good. Okay, so even though you don't have a constant, it means it must be 0 for you not to see it. So looking at the signs, 1, 4, and 0. And here we go, discriminants again. Discriminant is b squared minus 4 times a times c. We've got b, which is 4 squared, minus 4 times a, which is 1, times c, which is 0. And I can see that this will cancel out since it's times 0. So it's 16. And again, you've got now discriminant is greater than 0, therefore 2 solutions. So far, so good. So there'll be some questions they'll ask you just to simply state the discriminant and then say how many solutions there are. That's what they want you to know for now. Okay. Let's move on to the next page. Is the very last question. Example 3 is when I introduce back to exercise 3G, just to get you to understand inequalities as well. Let's have a look at this one. Example 2. Solve for the x-intercept or seps of the following graph, giving answers in exact form. So in this case, don't change the decimals. Don't use your calculator. You're going to then try to solve for this. Or if you use your calculator, make sure to keep it in exact mode, which I'll teach you. Here we go. How do we solve for this? You'd have to move the 3 across. You can't then say this is A, this is B, and then this is C. Okay, because you have to stick to the general quadratic formula of the equation. And the equation is ax squared plus bx plus c. All right? And we need it to equal to 0 to use the x-intercept. Yeah? So, minus 3 on both sides. 3 cancels out. And you now have 2x squared plus x minus 3 is equal to 0. And let's do this one now. Ben, what's my A, B, and C? Good. Using my quadratic formula. What is my quadratic formula again? X is equal to, let's go with Luke. Do you know the quadratic formula? It's on your page. Or the one before that, the one that I boxed around. Good. Perfect. This is your quadratic formula, and this will tell you the x-intercepts. So they said solve for x-intercepts. Traditionally, you're meant to factorize that. For those students, so last year I told the students who struggle with methods, I'm like, you can still do the exam, you know this formula, and it's always going to be in the exam. But if you can't factorize, then maybe think about whether you want to do methods or not. Because methods is about you learning how to factorize this. If you can do cross method, great. If it works, it works. If it doesn't, you have to complete the square. Worst case scenario is then just plug it in your calculator, fine. In your exams for next year, they expect that you can do this, all these 3 skills that I just said, difference of perfect squares, or completing the square, or cross method, or quadratic formula. You need to know how to do them all at your disposal. Okay? In this particular question, they actually just want you to use the quadratic formula, so I'm going to use it. Otherwise, normally I go for cross method first. Okay? So here we go. Let's use the formula. B, which is 1. So I'm going to write here negative of 1. Notice my layout. I'm using the brackets to make it clear where my negatives should go. B squared, so that's again 1 squared, minus 4 times A, which is 2, times C, which is negative 3, all over 2 times A, which is 2. Simplifying this gives me negative 1 plus minus square root 1. Negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24. Divided by 4. I don't have space here. I'm just going to draw another vertical line here. Equals to negative 1 plus minus root 25 all over 4. That gives me negative 1 plus minus root of 25 is 5 divided by 4. So that means you've got 2 possible answers here. You can either get negative 1 plus the 5 divided by 4, or you can get negative 1 minus the 5 divided by 4. So what are my 2 possible x-intercepts? You can have x is equal to negative 1 plus that, so that's 1. So 4 over 4 is 1. And negative 1 minus 5 is negative 6. So negative 6 on 4 is the same thing as writing negative 3 on 2. Coolies? So remember when you're sketching a graph, there are three things that you need. Y-intercept, x-intercept, turning point. Okay? If you couldn't factorize that before, this is another way to get there. So technically, if you were able to factorize, this is what it should have been. Bracket, bracket, bracket equals 0, and that's 2x, x, and I would say that's probably 3, 1, 2, and I need a positive 3 and a minus 1. There you go. So if I factorize that, you can see solving using null factor law, I would have got x equals 1, and I would have got negative 3 on 2. So last year with my year 10s, it's about, could you do this? Because if you can, you would have got the answer straight away. If you couldn't, this was your fallback. It's longer, but you will get your answer, exact same answer that I would have got from factorizing. So 3b, 3c is key. Okay, so you have to be able to factorize, you have to be able to solve. That's your first skill. Then you combine them all together. Cool? Now let's say that you can do them all. You can now do them all. Then in the next question, I know they said use quadratic formula. You don't have to. Use a lot of different things. This one, if you can cross method, which I'm not sure if you can, it might not be possible. You might have to use quadratic formula to get it because that means your x-intercepts are surds. I want you to try sketching this now. Okay, so the first thing is find y-intercept is the easiest one to do, which we all should know just by looking at the equation. And then find the turning point and find the x-intercept. Okay, I'm going to pause the video. You're going to get 5 minutes. So, y-intercept every one of us should have got. General form, let x equal to 0. Clearly it cancels out and you get 1. So everyone should get 0, 1. X-intercept is the next one. So I tested to see if I could do cross method. It so happens that you can. I saw it as 4x can be paired with a 1. And then 1x with 1. So therefore 4 and 1 gives you 5. So that was easier to do than doing quadratic formula for me. If that didn't work, I probably would have just carried on to this step to then solve for the x-intercept, just because I don't like using quadratic formula. I'm a bit lazy. Unless the numbers are really big, that's when I use quadratic formula, but that's to you guys. So I've got out the x-intercepts, I've got the y-intercept. Technically, you should get the shape of the graph now. The only thing you're missing is turning point. I like completing the square just because you get the x coordinate and you get the y coordinate in one go. But if you prefer using the formula, then you could have used the formula as well. Now, just to explain what I was doing, here I was really being explicit with what I was doing. Usually I cut down my steps as I'm going through it, but I'm showing you clearly what I'm doing. You can't do completing the square if the number in front of x squared is not 1. So it's currently not 1, so I had to take out a factor 4, even if it doesn't fit the 5 and the 1. So 4 divided by 4 is 1 here, 5 divided by 4 gives you 5 and 4, and 1 divided by 4 gives you that quarter. That's what it means when you're factorizing. It's opposite of expanding, hence you're dividing. Then from here, I did completing the square. So I said, you got x squared, you got 5 and 4x, and you got the plus quarter. What do you need? Well, we know that what goes in the brackets is half of 5 and 4. So half times 5 on 4, 2 times the 4 gives you the 8, and the 5 stays at the top. If it helps you, when you half, you just change the denominator, just times that by 2. Yeah? So I got 5 and 8, and I know that the square of 5 and 8 is 25 and 64. So I need 25 and 64, and minus 25 and 64. This is a perfect square, and I just had to calculate this by hand. So this is depending on how strong your fractions are. I can see in 4 and 64, so I did how many 4s and 6? That's 1, remainder 2, so 16. So I knew times this by 16, times that by 16, and I should get both 64s. Negative 25 plus 16 was 9, negative 9. It's over 16. Oh, sorry, negative 9 over 64, but I did a bit of a quick step here. Don't forget that 4. A lot of students forget that 4. It's 4 groups of this bracket and also 4 groups of whatever this was. And because I knew it was negative 9 on 64, 4 times over 64 can be simplified as 16. That's why I jumped a step. Okay, so I could have taken an extra step for you in terms of fractions, but I was scared it could get very confusing. All I'm saying is I did 4 times negative 9 on 64, and I knew that 4 and 64 can cancel out to be 1 and 16, and I did that in my head to get to this step. Okay, so I got expanded 4 times this bracket gives you that, and 4 times this fraction gives me that fraction. Why do I like the turning point for? Because you can read left by 5 on 8, down by 9 on 16, so that must be your turning point all in one step. Okay, yeah. You can use the alternative method was you could simply have gone with x is equal to negative b on 2a. And that would have been negative 5 on 2 times 4, which is 8. So you would have got that one. So you got the x1 of turning point. And then take that number and sub it in. So you could have done that. So you could then said y is equal to 4 times negative 5 on 8 squared plus 5 times negative 5 on 8 plus 1. And that would have given that. Same way. So it's up to you, whichever way you want. And that's why I'm saying you've got learnt these tools. You choose which one you're strongest at, and then you're more likely to do it efficiently and effectively, meaning it's accurate. Okay, I personally, it's just that my fractions and algebra is generally strong, so I stick to completing the square. That's my own personal bias, but you guys pick whatever works. Sometimes I flick back to this if I know the fractions are smaller and just do it. Yeah? There we go. So we would have sketched the graph. I've already done it on Desmos for you to see. All the points are there. So I'm just going to screenshot it. This is what your graph looks like. Now let's recap last session. I taught you when it's equal to, and then what you need to try to get your head around is when it's greater than, less than, and whatnot. Okay, so here we go. This is my graph. You got the x-intercepts. That's negative a quarter. That's negative 1. The turning point, which is in decimals, but we already know it's negative 5 on 8, negative 9 on 16, and 0, 1. Okay? Notice this question here, right at these 2 points. This point and this point. This is when the equation 4x squared plus 5x plus 1 is equal to 0. There's only one point that's equal to 0. And this one is also when 4x squared plus 5x plus 1 is equal to 0. So that's what you're familiar with. It's the equal signs. When we change the question in exercise 4G, I'm asking you now, when will you have 4x squared plus 5x plus 1? When will it be less than 0? Okay, so this is when y is 0. Where on the graph will you have a y value smaller than 0? Because remember, the reason why you can see the graph is because it's made of infinitely many points together with this pattern that you can see the graph. So out of all those coordinates, there has to be a set of coordinates that have y values that are smaller than 0. On the graph, you can see it. And what I can see is right here, this represents less than 0. That's when y values are less than 0. So all of these coordinates have a y value less than 0. When you're answering exercise 3G, you're really asking, well, which x values will make that true? There's only an x range, which is from here to here. Negative 1 all the way up until negative a quarter. That's the only path. No matter which x values you choose, they will have a graph. So if I chose this x value here, they will have a point that corresponds to a negative y value. See what I'm doing there? So that represents less than 0. So what's all of these points? How do you summarize that interval there? This is what we say. This is how you answer the question. X has to be greater than negative 1, but less than negative a quarter. Because between negative a quarter and negative 1, this, no matter which x value you choose, the graph will correspond to a negative y value. That's what it means when we say, when is the graph less than 0? Okay? That's what 3G is. So if I swapped it around now, let's see. What if I swapped the question around and I asked you, when will the graph 4x squared plus 5x plus 1 be greater than 0 then? Can you see it in the graph? So I want the y values to be greater than 0. And I highlight it now. This is greater than 0. That's the y-axis. Which part of the graph represents that? Which x values can I choose that will guarantee, no matter which x values I get, and I chuck it into this, it should be bigger than 0. You want to have a go. Mete.
Less than negative 1, not greater than negative 1.
Less than negative 1. Let's see if Mete is correct. If I chose a number over here, let's say I chose an x. If you go all the way up until you see There we go. Here's the point on the graph. But if I go across, that's a positive y value. It's true. If you chose one on this side and you connect it to where the graph is, here's the graph. That's the point on the graph. That corresponds to y greater than 0. So it's true. So it's true that if you keep choosing any points less than -1, for sure that's going to be true. But there's also another region, which Mete mentioned, that side. So you can pick a number over here, and you can see that as you move, where is it on the graph? It corresponds to this point. Going back to the y-axis, it's right there. That y-axis is positive y value. So looking at the graph, I can already see, when will the graph be greater than 0? Just pick any x values that is greater than -1/4. So -1/4 is that cutting point, that's when it's equal to 0. If you chose any x values this direction, be greater than 0. Or if you chose any x values less than -1. Okay, so anything that's less than this, you can see that the y values on the graph will correspond to greater than 0. This is exercise 3G. It's a bit conceptual, but you have to understand this before next lesson, which is discriminants, because it gets even more confusing. Okay, because you're used to seeing y and x. Next session, this is going to be called discriminant and x. And you're going to use that to refer back to your y and x. That's why a lot of students struggle with 3i. But you have to understand 3G first, to understand regions. That doesn't have to stick to one point. You can have multiple points. So you can have any x value greater than -1/4 and any x value less than -1. This will help you understand when I go to 3i. Okay? And that's pretty much year 10 revision. Up until this point, this is like intro to year 11. Everything before is year 10. That's you mastering your year 10 content, get the foundations right. And then next week, that's when we truly start year 11 methods. Cool? All right, you got your session. You got about 32 minutes. Have a go with either exercise 3G or 3F or whatever it is. Build your foundation. Make sure that year 10 part is feeling good so you can sketch. The ultimate goal is to sketch. What holds students back is BC, factorizing. After that, it's the theoretical part. Okay, so get your foundation right. Factorize and solve. You have to be able to do those. All right, I'm going to stop there.